Okay, for this exercise, previously Dr. Shima has shown you the solution using extent of reaction method. So for this one, I'm going to show you how to use atomic balance method to solve this problem. Okay, again I start with the block flow diagram. Okay, you have C2H6 as your inlet, and your inlet is 100 kilomole per hour. And the outlet, you have remaining C2H6, okay, and then you have C2H4 as your product and hydrogen as well as your product. And the question has mentioned the product have 40 kilomole of hydrogen per minute, and you don't know how much molar flow rate of C2H6 remaining at the outlet, and then how much of the mass flow rate for the C2H4. Okay, so we are going to obtain N1 and N2 here. So this is your variables. So in this, we're going to use atomic balance method. We start with D or F first. So first, how many unknowns we have? We have 2 unknowns here, which is N1 and N2. Okay, minus 2 atom. In this system, we have 2 atoms, which is atom carbon and atom hydrogen. So only 2 atoms. You don't have any other independence equation. You don't have any other independence molecular as well. So only these 2. So 2 minus 2, you have 0. So means you have 0 for your degree of freedom. Compared to extent of reaction method, if extent of reaction method, you have to plus with one chemical reaction. Okay, so you have this chemical reaction is C2H6 produce C2H4 plus hydrogen. So in extent of reaction method, you will include this in your degree of freedom. But for atomic balance, you don't have to include that part. Only how many unknowns and how many atoms. And if you have an other independence equation, then you have to include here. But for this question, you don't have anyone. So that's it for the degree of freedom. Now we can start with the atomic balance. How we want to solve the N1 and N2? We can start with the carbon balance first. Okay, carbon balance. Okay, again, this is energy balance equation. So we still stick to input is equal to output. Okay, we have input for carbon C2H6. Then how you going to write it? So you know it's 100 kilomole of C2H6, okay, in your input. And then how many carbons you have in C2H6? You have 2 carbon. So put it as 2 kilomole carbon in 1 kilomole C2H6. Okay, this is for the input part. 2 kilomole carbon because you have 2 carbon here, okay, in your C2H6 molecule. And then equal to, because you only have C2H6 as your input. Now we move to output. At the output part, you have C2H6 again, but you don't know how much of the molar flow rate. So you label as N1, isn't it? So put it N1 of kilomole C2H6. Okay, and then again you have 2 kilomole carbon. Okay, because you have 2 in this C2H6 molecule. You have 2 kilomole carbon in 1 kilomole C2H6. Okay, and then what else you have? You have C2H4, then plus. Okay, I make it at the bottom plus, you also don't know how much flow rate, so you put N2 C2H4. Okay, got this. And then again, you repeat again. How much carbon you have in this C2H4 molecule? You have again 2 carbon. So write down 2 more carbon for 1 kilomole. In 1 kilomole C2H4, you have 2 carbon. Okay. And then what you have again in the output, you have hydrogen. But in hydrogen molecule, you don't have C, you don't have carbon. So you don't have to include it in this carbon balance. Okay, because this is carbon balance again. This is carbon balance. 5. So you have 100, is it, times 2 here equals to N1 times 2 plus N2 times 2. Then you can simplify again to 100 is equal to N1 plus N2. So this is equation 1. This is for C balance. Okay, this is for carbon balance. Next, we move to hydrogen balance. Okay, remember this is atomic balance. So we work out one by one, atom by atom. Just now is carbon, now is atom H or atom hydrogen. So we start with input. So the input you have again C2H6. So you have 100 kilomole of C2H6. Okay, you have how many hydrogen atoms? 6. So 6 kilomole of hydrogen in 1 kilomole of C2H6. Okay, this is for the input part. Then equal with the output. Output you have C2H6 again. And again, you don't know this one. This is N1. C2H6. Okay. And then this is 6 kilomole of hydrogen. Okay, you have 6 kilomole hydrogen in this C2H6 molecule. Okay, C2H6. Okay, and then you continue with plus. What have you in the output? And then you have C2H4, which you also don't know the molar flow rate. Again, you write down C2H4. And then how much atom hydrogen do you have for this one? It's 4. So 4 kilomole of H atoms in 1 kilomole of C2H4 plus, okay, you have another product which is hydrogen. Okay, you know for hydrogen you have 40 kilomole. Okay, hydrogen. And then how many atoms of hydrogen? 2. So again 2 kilomole H in 1 kilomole hydrogen. And then we simplify the equation. Then it becomes 100 times 6 equal to N1 times 6 again plus N2 times 4 plus 40 times 2. Okay. Then we simplify and that will become 520 equal to 6 and 1 plus 4 and 2. So this will become your equation 2. Okay, now you have 2 equations just now. Okay, which is this one is the first equation and this one is your second equation. So then solve simultaneously, and then finally you will get result for N1 equals to 60 kilomole C2H6 per minute, and then for N2 you will obtain 40 kilomole C2H4 per minute. That's it.